My name is Dr. Nick Fazli Rosley from the School of Biological Sciences, University of Science Malaysia. So the topic of my presentation today is using Mathematica to study bees that are tricked into sex. All right. This is a term that you probably not familiar with. You might be familiar with the term of mimicry, which is an act of deception. So, and then most people would know about the Batesian and the Mullerian. But Poyanian is a little bit different. So if you were to Google, the first hit that you would get from the term of Poyanian is actually these species of special orchids, the Ophrys, aptly named as bee orchids. So the term Poyanian itself is actually mimicking the female species of the target for pollen transfer through pseudopopulation. Right. So this picture says it all. So this is a bee that is tricked into having sex with a flower that looks like the female counterpart of its species. So what's going on over here is where they were into pseudocopulation, the pollens get stuck to the bee's body, and then the bees would then move on to another flower, thus repeating the process and then transferring the pollen, right? Right, okay. This is one of the few questions that I usually get when I first did the study. I don't know whether it is beneficial to the bees or not. And then another question that I usually get is, don't bees learn from it? Apparently they don't. There was a study that actually did the comparison of the timing in which the bees tried to pseudocopulate with the flowers, and if I'm not mistaken, the longest was about a minute and a half or something, and then they apparently went to another flower and tried to do the same thing again, right? So that's a totally different study at all. All right. Okay, so if you were to have a look online and then see about the physical characteristics of these flowers, there's actually hundreds of genus and species of this Ophrys. Then they are really remarkable in the sense that they actually do really look like the bees, or in certain species wasps. It depends on which pollinators that targets them. All right. So can it fool a machine though? All right. So it starts off with a very simple question. So we use the simplest method, which is the classify function in the Mathematica. So we get a bunch of images from Google Image, and then we just classify them. We train the algorithm, and then basically we just want to see that if machine learning can actually pick up the differences. Is it going to be good? Is the deception good enough to actually beat a machine, right? So we use several hundred of images, and then we use the 80-20 rule. 20% of the images were used for tests. And then we only focus on the four most common species of the Ophrys, which is Ophrys epifera, insectivora, bombliflora, and speculum. All right, so this is actually an example of an output that we got. So we compared based on the accuracy, the baseline, mean cross entropy, and then there's another that wasn't specifically mentioned over here, the ROI, area under curve. Right, those are the normal classifiers that if you were to compare the accuracy of a machine learning algorithm. All right. Okay, and then we also use image key points using and similarly image highlights to highlight the 100 strongest points in the image. They were done using speeded up robust features, the SURF method, but we only use them to the images in which the machine learning got it wrong. Okay, so we're actually in the results. So as predicted, the machine learning actually performed brilliantly. So it is almost 100% accuracy in almost all of the cases, but it's not perfect. as you can see from the results over there, they do get a few errors. They misclassified a few images. So we took those misclassified images and then we subjected them to the surf method. And we wanted to actually see what are the key highlights that managed to confuse the machine learning. All right, so this is what's going on. So as you can see over here, the top one over here, the A and the F is actually two types of species of bees that are usually associated with this orchids. As you can see, the strongest key points is totally very different. The machine can actually determine and say that this is actually an insect. It's not a flower. But when we go more towards details into the characteristics of the flowers, the orchids themselves, we can see that the highlights are everywhere. So the machine is very capable and they are very accurate in responding to this, right? So that's one part. So we can honestly say that machine learning is not fooled by the orchid for obvious reasons, right? The second portion that I would like to highlight is that we are not actually comparing how bees see and how a machine learning sees. Those two are completely different area. So it is not fair to compare it. But what we found out was all of these, the image highlights, actually supports traditional descriptive results of classical orchid taxonomies. All right. So the parts where the surf method actually highlights and labeled as one of the few, the 100 strongest key points, the lateral sepal, the speculum, the pseudo eyes that actually looks like the eyes of the bees, the basal field, they correspond to the descriptive physical characteristics that had been described by taxonomists before. All right, so again, these are the parts that would closely resemble the bees. So this is a very early attempt to use machine learning. So this is just a preliminary, if I'm allowed to say it. So this is actually an attempt to turn a qualitative description into a quantitative measurement, right? So because previously, a lot of this natural history or the physical characteristics of flowers or even animals, they are usually described by traditional taxonomists, botanists, and everything. So it's mostly description, right? So even though there has been an improvement and there has been new researchers that uses image analysis, but it's still lacking. And for this example, the Ophrys, if I'm not mistaken, my study is actually the first one to actually try to bridge the gap in which you're trying to describe things just by description. And now you're using AI to help you describe those things and to actually pull out the physical characteristics that is the strongest points or the most interesting physical aspects of that particular species, whether it be it a flower or an animal. So this is something that we're actually trying to do in the future, right? So actually, I've published a paper on this. This is if you guys are actually interested in reading it. And that's it. I look forward to your comments and suggestions. Thank you.